Hi everyone, I'm Paloma and I am Product Specialist in the Smartworks IoT team. Today, we will be talking about the smart product development. The purpose of this session is to show the solution offered by the Smartworks IoT platform for the development of connected products and all the things needed to complete this process successfully. After a brief introduction, we will be analyzing a real use case where we have helped a motorcycle company to enhance its business development by using Smartworks to build a smart product, and finally we will dive into the product itself. As you may know, over the past years, product development has been focused on product design and product engineering. But the new trends that have appeared made us start thinking years forward about the future of product development. So that's why we have evolved from tools that offer generative design, topology optimization, and mechanical and electrical simulation to smart product development, offering tools for embedded development, software development, and continuous improvement. You might be thinking, why does all this mean for any company, and why developing a smart connected product is something relevant for a business. And typically we have three main use cases, which are that you may want to improve your users' experience and give them control over the product. So imagine, for example, you are a motorcycle manufacturer company. It would be nice to provide your users, who can be owners, rental companies, or servicing firms, with an application that will enable them to monitor and control motorcycles on the field. Another option is that you want to offer your product as a service and therefore obtain recurring revenue streams, for example, as a motor sharing company. Or maybe you just simply want to improve operations and streamline processes and keep your assets running as long as possible, with the highest efficiency and the lowest cost. So if you are planning, for example, to take part in a competition, tracking the different parameters of your motorbike after each lap will be really useful, as well as having information in real time about how your system is performing. To achieve any of these goals, we need to develop a connected product, and this involves managing an ecosystem that is made up of different pieces. As you can imagine, this process can be a bit complex, because developing an IoT software ecosystem is not only about designing the front end, such as the web or mobile application that your users and yourself will use to track the performance of your motorbike, but it also involves edge, DevOps, and backend development, which are crucial pieces of the ecosystem. The edge allows you to manage devices in the edge, so you can monitor your motorbikes, update their software systems, and easily iterate on their design securely. DevOps will ensure that these services are up and running 24/7 and, if necessary, scale to meet demand. And backend is the one that orchestrates all the interactions between devices, users, and the logic required for the product itself. So this is where Smartworks IoT stands out, as a low-code application development platform. Thanks to Smartworks, the process of building the IoT software ecosystem mentioned before is simplified, while reducing costs and risk when developing your smart connected product. Smartworks is the linking piece between all your devices, which are the motorbikes, and your end users, who just want to use a fancy app and don't really care about how the database is built, how the data is being collected from the different motorbikes, or how the management of the fleet is being done. If your use case scales and you end up having so many motorbikes you want to control, you might not want to go through the whole process of developing an application for understanding how your fleet of motorbikes is working. In that case, you just want to visualize the data you have been storing in Smartworks and analyze it in real time to be able to draw relevant conclusions. And for doing that, we have Panopticon integrated to design powerful dashboards easily. If your use case gets more complex and you need to rely on heavy computing and the edge so that you are able, for example, to deploy complex machine learning models on your motorbikes, you can also use Smartworks to help you deploy and manage all this code at the edge. In the end, what we offer is a modern, scalable, collaborative, and secure solution that provides modern interfaces for developers to create an application in a cloud-native architecture, so that you can choose your cloud provider and deployment infrastructure. All of this with modern languages and modern open toolsets that ensures that your product is scalable and performant from the beginning. What we achieve with Smartworks is to do more with less, The application and the use case is still under your control, and we just provide the underlying tools so that you can be the best at your use case. And all this while ensuring scalability and security, allowing you to perform faster iterations and providing a flexible environment that adapts to each case. The features that differentiate Smartworks from others are that it is a platform especially designed for product developers, so it has all the necessary tools for it. We are cloud agnostic, so you can deploy Smartworks in any cloud service, so your data will be stored in the place of your choice. We can deploy on-premises to connect thousands of devices from multiple locations securely. And it is also integrated with other Altair tools, right now with Panopticon visualization and stream processing, but we are also integrating with the Activate tool and planning to integrate with many more. And finally, all of these come under the same units business model, which lets you take advantage of Smartworks in the most convenient way for your business. To understand better the motorcycle use case or any use case, we can use Panopticon, which is integrated in a Smartworks IoT platform. It is an Altair tool that helps to visualize data flowing into the platform. Thanks to this tool, you can have an overview of all the information that you have in the platform, perform analysis over it, and also see how you plan to show the data to the different end users. In this case, we have designed 3 different dashboards. Each one of them has the data to perform different analyses. First dashboard is the control dashboard. It summarizes the information that will be relevant to have control over the whole fleet of motorbikes. First part shows where each motorbike is located at the moment. The color is representing the health index, which is a parameter that we have created to set up how well the motorbikes are performing based on other parameters. To understand this health index parameter better, we have created a heat matrix chart showing how the motorbike health index changes depending on the different models of motorbikes and the year. And we also have a scatter plot to analyze the dependence between the battery and its capacity. In this case, size is representing the number of kilometers driven by each motorbike. And finally, we can also see the distribution of the motorbike speed related with the number of kilometers driven for the different years. These visualizations can be further customized by applying filters. We can choose to see, for example, the detail of this motorbike that has a real low health index. As you can see, the rest of the graphs have been updated with the information of this specific motorbike. Based on this analysis, we may conclude that some of our motorbikes might require some maintenance services. So that's why we have the supply dashboard. This dashboard helps us to know the current inventory, the demand we have, and the orders that we have made to meet this demand, and also their status. Also, information of the already inspections schedule can be found here. Last dashboard shows the information that our end user might be expecting to have so that we help the rider manage their motorbike by showing the trip records, last trip, motorcycle status, and any scheduled inspection, everything in a single view. Now that we have the idea in mind of what we can achieve with Smartworks, let's understand how all this is done. If you want to join Smartworks IoT, you just have to search for swx.altair1.com. If you already have an account, just enter your username and password and click on Login. If not, let's sign up. Once you have verified your email, you can finally log in. Right after logging into Smartworks, the following welcome page appears. First thing is defining a space for our project to live in. We are going to name it and click on Accept. Note that there are some restrictions regarding the space name. You just must enter at least 3 characters, and it cannot start with an uppercase. Note also that special characters are not allowed. Spaces work as isolated work environments to build the different smart product applications or projects that you want to host inside Smartworks IoT. So you can keep on creating different spaces. Deleting a space is so easy. Just enter your space, click on Space Settings, General, and you can delete it. When we create our space, the name that we are setting is the ID of the space, but we can change this name. Enter your space. You can change the name that is displayed on the space card and over here. Uppercase I'll allow here, and also spaces and special characters. Check how the display name has changed. Last thing we can do from the space settings section is customizing the color of our space. That means the color that is going to be displayed on the welcome page. Once we enter our space, you can see on the left the different modules in Smartworks IoT. Thanks to them, we will be able to set up our database, deploy custom logic, manage access control, and create dashboards in a collaborative, secure, and low-code environment. Inside AnythingDB, to organize our database in a logical way, we can create collections to group the different entities and enable fine-grained access control over it. For the purpose of this example project, we are first going to create a collection to store information about the different motorcycles. Next, we are going to add the first motorbike to the collection. Each entity can have a set of properties to define its attributes. For example, we can define distance to NTIP, so that we can know the approximate distance we can drive with the battery power remaining. We can also add actions that will help us define a standard interface for requesting commands like instructing the motorcycle to turn on the lights. And finally, we can also set events to define a standard format for reporting information, such as when the battery level is low, so that we are notified to charge it soon. We can keep on adding more properties to perfectly define the parameters we want to track from our motorbikes. Note that you should at least enter the title and the type of property. Once we have all the properties defined, we may want to reuse this configuration to create multiple motorbikes. For doing this, we just have to save thing schema as a model. Models are used to define a template to create new things easily and quickly. Click on the Edit Schema button and choose Save as Model. If you don't have a model created, we can just create a new one. Just name your model and click on the Add button. The defined thing schema will be stored inside this model. We can now check at the Models tab that the model has been created with all the attributes defined. New versions can be added based on this one if any improvements are required. The thing schema that we have stored provides a standard schema definition for the motorbikes that we are modeling. It is compliant with the Web of Things theme description and is built on top of the popular JSON schema definition. Following Web of Things provides a set of standardized technology building blocks that will help to simplify IoT application development. You can send data to Smartworks IoT from a thing. To do this, you need to create a connection between Smartworks IoT and the object to send the data. Data must be sent via HTTP or MQTT. If you want to connect via HTTP, the platform offers access through a REST API to all the resources. You can also send data using MQTT protocol. MQTT is the standard for IoT messaging. It allows for messaging between device to cloud and cloud to device. It follows a publish-subscribe pattern that decouples the client that sends a message, the publisher, from the client or clients that receive the messages, the subscribers. Client connections are always handled by a broker, which is responsible for receiving and filtering the messages, determining who is subscribed to each message and sending them. AnythingDB generates a unique set of HTTP and MQTT credentials for each motorcycle in the system, which allows the device to bidirectionally exchange data with Smartworks. As you can see, this feature is really helpful to ease the process of provisioning the information of multiple motorcycles using the model defined before. Historical data sent to each motorbike can be found in the raw history section. As you can see, the incoming data from the different sensors of your motorbike is received here and then stored. Following the same process, you can add more collections to store different information. For example, you can have an orders collection to store the information of the different orders that you have made to require new types of parts. You can have another collection to store the inventory of all the parts that you have. And you can also store the information of the different users. Coming back to AnythingDB, let's see what other customizations we can make. From here, you can choose which columns to display. And you can also reorganize the order between them. I can filter, for example, to see the motorbikes with a battery level below a certain value. Filters can be easily removed from here. If you make an improvement on the version of your model, you may want to update all your motorbikes to that specific new version. For doing this, you can select all the motorbikes from here, click on Edit, and apply the new version to all of them. Now that we have our motorbikes database defined, we may want to define some business logic quickly. This can be easily done thanks to the Functions module that enables you to create and deploy custom code on the Smartworks IoT platform without provisioning servers or building an API. You can write these business rules in Python, Go, and many other programming languages. When you select a programming language, Functions auto-populates the basic structure in the code editor. In this case, we are going to create a function in Python that generates a low battery event when the battery level falls below a selected threshold. Add the code and save to start the building process. Once it is completed, the status will have changed from pending to building and then to running. When the running process is completed, you can execute your function through HTTP or by linking it to an MQTT trigger or a cron trigger if you want to schedule its invocation. As we have to define an MQTT trigger to execute our function, we have two options. We can create a function referring to a specific thing, but if we want our function to be affecting multiple motorbikes, we will have first to create a label, so that we can assign this label to the different motorbikes that we will be monitoring. Using a label is the best option as they also have MQTT credentials. Labels can be found in the Space Settings section. To create a label, you just have to click on the new label, name it, and you can apply a color to them. This way you can have multiple labels and identify them easily. Once the label is created, we can move to the security pane. Here we can generate the credentials. If you want to create new labels for any other purpose, you can add them also from the AnythingDB section. If you haven't created your label, you can just type it here and click on Create Label. The label will also appear now at the space settings, and you can customize it from here. The topics to subscribe to the different motorbikes that we will be monitoring can be also found here. Let's copy it and use it as the event trigger on our function. In this case, we'll be specifying also that we want this function to be invoked whenever there is a change on the properties battery of anything inside the collection's motorbikes that is labeled with this specific label. Last thing we need to do is to define a trigger. Triggers are components that convert incoming messages to HTTP requests to asynchronously invoke all the functions that match certain criteria. From here we can create MQTT triggers but also cron triggers. To create an MQTT trigger, we need first to enter the host. In this case, username and password are the credentials from the label that we created before. The topic that we are adding is for listening to all the properties of all the things inside the collection's motorcycles that have assigned the label that we have created before. If you want to know what your trigger is listening to, you can also set up a callback URL. Let's test our function. First thing we need to do is to assign the label to the thing that we want to be monitoring. Let's try and change the battery value. By entering a low battery value, we might have received an event. Check here that the event was received with the data of the battery level. You can also check the message received at the callback URL. Remember, you can always come back to your function to make any changes needed. For example, you can add a cron expression, make any change on the code, and also test it from here. This way you will know if the logic applied is working as expected. You can also check the number of times your function has been invoked. Following the same structure, you can keep on adding more functions. For example, you can create another function to calculate the capacity, health, and kilometer, which are parameters of our motorcycle, based on the battery level. You can also create a function to calculate the health index, which is a parameter that measures how well the motorbike is performing based on the properties kilometer, health, and distance to empty. And finally, you can also create a function to update the state of your motorbike based on this health index. By now, your application is almost ready. Let's say you want to accelerate the development process by inviting your peers to the project space and begin collaborating in the shared space. At the same time, you will want to ensure that the users have the right level of access to the right entity in the platform. With the access control feature, you can create from general to fine-grained permission and set authorization rules for every piece of your IoT platform. In access control, from the users section, you can invite new users to join your space, but you have first to define a role to assign to them. Let's move to the roles section. The platform creates a default root role that can create, read, update, and delete any resource on the account. Let's create a collaborator role so your colleagues can act on your behalf on the platform. That way, users assigned to it can read and update the resources. However, they cannot create or delete the resources in the application. As you can see, you can easily add the policies for the different sections of our platform. Note that you can also change from allow to deny. You can also add custom policies from here. Just choose the section where you want the policy to be added and click on the resource type. From here, you will be able to check the subjects that you have assigned this role to. To add a new subject, click over here and enter the subject name. You can keep on adding as much subjects as you want to. Let's invite a new user using this new role. When a user receives an invitation, they appear in the Space Picker section. From here, the user can decide whether to reject or accept the invitation. When they accept it, they have joined the space and they can enter it. If you want to integrate with third-party applications, you can use apps and set the permissions needed for them. For this project, we have created an app to do the initial provision from a Python script. You can choose the scopes and get the credentials from here. Never forget to set up the policies. Now we are almost ready. The last thing that we need to do is to create our dashboard. Panopticon can be accessed from here in the real-time visualization section, clicking on the workbook section. Every user has its own root folder created where all the workbooks are stored. To create a new workbook, just name it and click on Create. First thing we need to do is to add a data table to fetch the data that we want to display. There are several global data tables available from here. We are going to choose the one for getting the historical data. You just have to enter your app credentials, the client ID, and the secret and click on Generate Columns. See how all the properties available are displayed. Click on Refresh Preview to have a general overview of all the data available. Now let's go back to the dashboard. Draw a square with the size of the visualization that you want to draw. You can choose from a wide range of options. By drag and dropping, you can customize your visualization. In this case, I want to plot the battery levels of the different motorbikes, and I want the color to represent distance to empty. Color palette can also be customized. You can choose how to aggregate the data, how to order the data, and you can even add a title. You can also convert this file into a PDF to share your results. You can also easily access the data from here or zoom in to see in more detail. If you want to share your dashboard with your colleagues, you need to give permissions to them first. Give permissions by clicking on your folder, Permissions, and allowing the users that you want to. You can also choose how you want them to access your workbook. Finally, let's see a small real implementation to fully understand what Smartworks is capable of and how to use it with the application that you are going to develop. Imagine you have an application like this one, and from here you are able to limit the speed of your motorbike to a certain value. Let's see how after setting the speed and clicking on the Set New Speed button, the property speed is updated with the new value on real time. This is also a good example to show another feature that the Smartworks provides, which is the MQTT inspector. MQTT inspector allows you to track incoming messages to any of the entities that you have modeled. You can access the MQTT inspector from the utility belt, clicking on the MQTT inspector. A list of the messages and topics is shown, so you will know what topics are available. Expand the nodes of the topic tree to see specific details of the data. Whenever a new message is received, you can check the history values, last value, and even add more topics to be subscribed to. From here, we can also access function log. Logging enables you to know what is happening during the execution of a function. You just have to choose the function you want to inspect and make a change so that it can be invoked. Let's try with the low battery event. Whenever we enter a low value, we see that the post request was created successfully. If we enter a high value, and so the event is not triggered, we also get the message telling that no content was generated from this event. Functions log can also be accessed from the Workers section, clicking on a function, and on this button. To end this small demo, let's try the last feature of our application, that was turning off the lights. Once we click on the button from turning on the lights, a progress bar appears until the action is completed. Once it is completed, we can switch to Smartworks and see what happened on the application. Check how the action was received successfully. If you want to know more about the Smartworks, you can always check our documentation. Here you will also find a tutorial about connecting your first device. Each of the sections in Smartworks has also a link to its documentation section. Now that you have discovered how easy it is to configure product ecosystem, leveraging all the various tools provided in the Smartworks IoT platform, I encourage you to visit us at swx.altair1.com to learn more and register for a free account to try all this by yourselves. Thank you for your time.